Hello everyone, my name is Andrea and I'll be walking through chapter F2.1, Interpreting Image Classification today. So get started, this is just an outline. We'll go through the chapter overview, talk a little bit about theory behind image classification, and dive into the practicum where we look into the scripts we have prepared. There's a link here to access these slides. So it's just bit.ly slides_F2.1. A little bit of the chapter overview. So the goal of this chapter is to introduce the concept of classification and walk the users through the many options for image classification in Earth Engine. Some of the learning outcomes will be running a classification in Earth Engine, be understanding the difference between supervised and unsupervised classification. We'll learn how to use the Earth Engine geometry drawing tools. So we'll be doing that to collect training data and how to collect sample data in Earth Engine. And then also learning the basics of the hexadecimal number system. Maybe we have talked about this in the previous weeks, but if not, or if you're new, we'll talk a little bit about this. And this assumes you know all about, not all about, what we've explored with images collections, filtering and visualizing, which is the F1 part of the book. And then we also expect you to understand bands and how to select them, which is related to chapter F1.2 and chapter F2.0. So let's go a little bit through the theory. So image classification. In remote sensing, image classification is an attempt to categorize all pixels in an image into a finite number of labeled land cover and or land use classes. So usually we have an image or a composite that is composed of different bands. And then what we get that information from the bands and classify that one image into different classes, which is represented here in this picture. I wanted to highlight a little bit the difference between land cover and land use. A lot of times these terms I use like interchangeably. So I just want to talk a little bit about this. Usually when you're referring to land cover, it relates to the physical characteristics of the surface. And then land use refers to how this land is being used by people, so by humans. This is a very simple example. In this case here, we have this plot of grass. And then, for land cover, we could say this is herbaceous vegetation, right? It's a type of vegetation, the grass. It's, short vegetation, is not like the forest or anything like that. So we could classify this into herbaceous vegetation. But for land use, since we classify this into, how people are using this land. This could be a pasture, for example. It could be, a pasture field. Could be also a park if we are in an urban setting. So, it's important to pay attention to what you're trying to classify, for the objectives of your project or work. If it's land cover or if it's land use, if sometimes we do classification using the two. So I just wanted to highlight a little bit about this. And let's go into the code. So if you haven't already gotten access to the book scripts, here's the link to the repository. If you don't see it under your scripts, which will be shown under the reader tab, you can press the refresh button and then the complete repository should be there. Also, we have this slide. It's, we'll walk you through here this chapter, but later when you're working the script by yourself or testing different parameters or numbers or anything like that, if you run into an error or if you need help with the functions, you can use the documentation tab. There's a question mark in Earth Engine that gives you access to a lot of places to go to look for support, such as user guides and other guides. And also Stack Exchange is a great place to find help. So section 1 is related to the supervised classification, and supervised classification use the training data set with known labels and representing the spectral characteristics of each land cover class of interest. So it supervises the classification. we feed training data into a model, and he learns how to use that data to make classification on an image. And usually the workflow is like this. So we first get a scene or composite of the area of interest. We then collect some training data. We then select and train a classifier using that training data. And then lastly, we classify the image using the select and trained classifier. This is just a scheme showing how this works. So usually you have your satellite image with different bands, and then for the reference data, which would be the training data here, you can collect create these points. For example, they can be points or polygons, but usually you draw them on the image. And then at each of these points for the classes that you have, you can extract all the spectral information of the image. So like for each of your points, which you have different classes here, these are just examples, forest, water, and developed. You extract all the spectral information for the different bands of your image. And then you can train your classifier, and at the end you have this output, which is an image where each of the pixel is labeled with the class that you elected. So the step one that we'll be doing for this section, we'll be selecting a Landsat 8 surface reflectance scene, cloud-free, almost cloud-free if I'm not mistaken. And then we'll use the geometry tools to collect training data. So I'll show you how to use that this tool to start collecting some points for the training data. And in our case, we work with these 4 classes of forest, developed, water, and herbaceous. And we use these class codes when collecting the points to differentiate the classes. So each of our points, depending on the class that they belong to, they will have a class property, which we will assign these numbers to. So go ahead and exit here my presentation to go to the code editor. You can also click on the code checkpoint here, because we'll be working with this first code checkpoint. So here I have the book repository here, and we work with fundamentals. We are in F2, interpreting images, and then we are in F2.1, interpreting an image, talking about classification. And I'll just open this first checkpoint. At the same time, I will open a new tab here and just open a blank script in Earth Engine. I personally like to copy and paste bits of code and explain them, so I'll be doing that. So here I have the complete script, and on this other tab, I just have a blank script. So to start off, I'll copy the entire code actually. So let's just go ahead and copy the entire code and paste here. The only thing we won't have are these imports, which I'll be talking about them in a minute. But first, I'll just run this bit of code. And you can see that, let me hide the map for a second. We are first just defining a point. So we'll be working, Jeff was right, we'll be working in Italy, so close to Milan. And we are defining a point where it's close to the city. So we're just using the ee.geometry object, and we want specifically a point. So we do dot point, and these are longitude and latitude information that we need for that point. Then, as mentioned, we'll be working with Landsat 8 collection, surface reflectance. So you've seen this already if you've been attending these sessions or checking the videos. We're using the most well-processed Landsat image collection, and we'll be featuring it by the point that we have just generated. So we want images only from that location, and I'm featuring to images only from 2019. So featuring by date, and I'm sorting by cloud cover. This means that in my image collection from images all from 2019, I'm ordering them following this cloud cover property. So images that have less cloud cover will be put at the top, and images with a lot of cloud cover, which will have like 90% cloud cover, will be down at the bottom of my image collection order. And I'm calling first. So this means I'm picking just the first image of my collection. So the result of this code block here is one image, which is, we can say it's the least cloudy image. And then I'm centering the map to that image. So I'm using the map.center object. I'm saying I want to center at the image, and I want the zoom level of 8. And then I'm defining some visualization parameters here. So I'm just using the RGB bands here, band 4, 3, and 2, and I'm defining some spectral values here for my image visualization. And I'm adding that image to the map. So if you run that code, you can see that this image gets added to the map. It's right here under my layers tab. And you can see if we zoom in, we might find a small cloud somewhere, but it looks pretty good, right, in terms of cloud cover. And if I change the transparency here, we can see that Milan is here at the top left. Then we have all of these other cities along the way. Now that we have a scene, if you remember our workflow, we first choose a scene, then we start collecting points. So we'll be starting first with forest points. That's the first class that I showed in the slides, and we will be collecting points. So here in the geometry tools, so this part here on the top left of the code editor are the geometry tools. So you have the hand, which is what's by default turned on, and this lets you pen the map a little bit. You have a point, a marker object here. You have a line, you have a shape or polygon, and then you have a rectangle as well. So since we'll be collecting points, we'll choose the marker option. So once I click this, you can see that this geometry imports section just appeared here on my screen. And you can see it has a default name for geometry. So we basically created a geometry just by clicking at this point. And if I return here to my script, you can see that this import also shows up here under my imports section of the code, which is here at the top. So what we will need to do, we'll click here on this gear icon to edit this layer properties, because we need to change a few things. So first, we'll be changing the name of this geometry. We'll be calling this forest. Since we'll be collecting forest points, I want this geometry to be called forest. And we are not going to work with the geometry. So if you remember, geometry is just the basic, vector, foundational vector data in Earth Engine. We have feature, which is a geometry, but with property information associated with it, so like an attribute table. And we have feature collection, which is collection of features. And we will be working feature collection because we are going to collect more than one point, and these points will have property information, which is the class code. So here, import as, we want it as feature collection, and we need to add a property to it. So this allows us to identify the class that we are collecting. So for property, I'm going to call this class, and I'm going to assign the value of 0. So all my forest points that I collect on the scene will have a value of 0 associated with it. And we can change the color as well. So for forest, what's intuitive, I'm going to just choose a shade of green here. And once I change this all, I can click OK. So now you can see that my geometry name here changed to forest. The color here also changed the color that I chose. And if I go back here to my imports section, it changed the name as well. And you can see that it's a feature collection now. I think before it was a multi-point object. Now it's a feature collection. And it says it has 0 elements because I haven't started collecting the points. So now that we've created this feature collection, you're already in point drawing mode. So if you click on the map, that will place a point on the map, and that will get added to your forest feature collection. So for this exercise, we'll be collecting 25 points for each class. And now it's a little, you'll be working on your screen. I'm working on my screen. I just want you to pay attention a little bit to where to place these points. So it's, since we have this entire scene, it's always good practice to place points, throughout in all the extents of the scene. So I could just place 25 points here on these mountains here that have this forested cover. But it's good practice to place them distributed on the scene. So just go ahead and place 25 points. I'll place one here. And you can do it on your own. You can follow me a little bit. I'll just keep going once I'm done. So you might want to wait, or if you want to just start and then stop when I stop here, that's fine as well. So I placed one there. You see, if I make a click, the point gets created. I'll point one here. Another one here. So just looking for this vegetated areas that are dark green. And it's important that you work with the scene that we have right here. I could use the satellite base map, but that doesn't reflect the current, the date that I have for the image, right? The satellite base map might be just a composite of different dates. So we need to work with the scene that we have because we'll be using the scene for classification. So point another one here. And you can check here, it shows how many you have drawn. I have 7 points, 8, 9, 10. This takes a while. It's a very, it takes time, it takes, it's effort, but it's a very important part of the process of classification. If not the most important. Because your model will rely, your supervised classification will rely on this training data set. So just do this. I have 20, I have 5 left. And now I have 25 points. They're spreaded. Now that I'm done with this class, I can move on to the other class. So I'll just check quickly. The next class we will be collecting points will be developed. So now that I'm done with this one, I can click exit. This will turn off, the editing process here. And I can go here on the geometry imports again and click plus new layer. This will create a new layer. And I'll do that same setup again. I'll go here to the gear icon so I can edit this layer property. I'll call this one developed. I'll change here the type to feature collection. I'll add a property. I'll call it class. So it has to be the same name. Since we'll be working with these points, we have to have the same property name for all of them. So make sure you have class, and if it's, if you change here, if it's lowercase or uppercase, it matters. So make sure you keep consistency here. And I'm gonna assign the value of 1. So I have 0 for forest, and I'll have 1 for developed. And I'll choose the color red for this class. Now again, I have a new feature collection here. I have 0 elements. And I'll look for mainly cities, right? We're talking about developed. So in this landscape here, we're going to look for cities. So I know that Milan is right here. So I'll go ahead and place some points there. I'll zoom in. And besides distributing our pixels, your points throughout the image, the entire footprint of the image, for developed class, for example, we might have some red rooftops, we might have some white rooftops, we might have some streets that will have this like dark gray color for asphalt. So it's important to distribute your pixels in these different features to make sure you capture all the spectral variability of your class. So I'm going to distribute some points here in these red rooftops, some of these very bright ones here. These here are streets. Let's see. Let's try to interpret this. Yeah, these are streets. So these pixels that are darker, that are on the urban area. Here we have also some very bright rooftops. I'm going to put some points here. Now I have 10 points, and I'm going to look for another city. I know there's another city down here, a small town maybe. So this one, Pavia. So I change a little bit. I'm going to shoot some points here on the asphalt. Let me see. You can use the satellite-based map here to help you interpret what is, my more high resolution, what's below. But making sure your final decision is based on the scene that you have. So here. Let's see if I can find. There's another city here, a town. And now I have 25 points for the developed as well. And I'll be doing this for all of my classes. So in order to save time, so otherwise we'll spend a lot of time here collecting these points. This has been done already in the code checkpoint. So you'll be doing that for water and herbacées as well. My advice here for water, for example, I'll show what we have currently for water. For water, there's a sea down here, the Gurian Sea. So we can collect points here at the sea. And you can see that in this particular scene, there's a difference here in the color of the water, like turbidity. So it's good practice if you collect points here in these darker waters and also in these ones that are brighter. The spectral information here is different. So make sure you collect points there. And also make sure you collect points. There are some rivers here. So make sure you collect points as well along the rivers. You can see that the color of the water here on the river is different from the ones in the sea. So it's good because it also will capture this difference in spectral variability. So in the end, what we want to have is these 4 different feature collections that will have all the information. It will be your training data that will provide information for your classifier. If you want to delete a point, you can simply click on a point and then the option to delete it will show up here. So you can just click delete. Another thing you can do is you can select a point, hold the mouse click on it, and move it around. So you can also replace points if you want. Once you're done, make sure you click exit here. And if you want to add any of your collections, for example, looking at the points here, in order to activate these herbaceous points, for example, I just need to click on the feature collection here under geometry imports. This way, if I want to place a new point, for example, or delete one and add a new one, once I click here, this name gets highlighted. That means the editing tool is activated. So now if I click on the map, I'll have a point added to the collection.